There is a pH scale that measures acid and base. Okay, and so
Base, neutral, acid.
right, there's a neutral. Right, do you know what number on the pH scale is considered neutral? 7. Good. Right, 7 is considered neutral on the pH scale.
Is it 12?
It goes to 14.
Yes. So
7's in the middle.
Acid, right? Or is that base?
For our basic definition of acids, we need to know that acids are what we call proton donors. Okay, acids are proton donors. Okay? And when we talk about protons, we need to kind of have a working definition of what a proton is. When we say it's donating protons, we need to know what that means. Okay, not kind of the nucleus. Is there an element that consists of just one proton?
No. Yes.
Hydrogen.
Hydrogen.
Hydrogen. A hydrogen atom consists of one proton and one electron. Hydrogen atom consists of one proton and one electron. But if I just start looking at H plus, that means now I'm talking about a hydrogen atom that has one proton, no neutrons, and no electrons, right? Which means it's a proton. So when we say we're talking about acids that are proton donors, we're talking about compounds that can give away a hydrogen atom. Okay? That makes it a proton donor. You can give it away. Okay? So that means acids have to have what element in them for sure? No, what element? What element? Hydrogen. Acids have to have hydrogen. If they're going to donate a hydrogen ion in the form of a proton, they have to have hydrogen to give. So acids, they always start with hydrogen, right? It's a really good clue for us that it's an acid if it starts with hydrogen. So these are some, I'll give you some examples. HCl, H2S, H3P. Those are all examples of acids. Okay, those are all examples of acids. Okay. These three are all examples of what we call binary acids. What do you think binary means?
2.
Binary acid means probably what?
2.
Two, okay, no, not two acids. 2 elements in the acid. What does one of the elements have to be?
Hydrogen and then another one.
Right, so a binary acid contains hydrogen plus something else.
Would it be a nonmetal?
Okay, right, usually a nonmetal. Good. Okay, hydrogen is usually, most of the time it's going to be a halogen, but really it can be any anion. Okay, any anion could go paired with hydrogen to make an acid.
Is it always negative?
When would it be a metal? Yeah.
It's always going to be a negative, right? It's almost like an ionic compound, except we know that hydrogen goes first. Okay? So, acids are formed when we have hydrogen plus something else. That's called a binary acid. That just means 2 elements. Okay? The other main type of acid we're going to talk about is called an oxyacid.
Is that with oxygen?
Good. An oxyacid probably contains, it has to contain oxygen. What else does it have to contain?
Hydrogen.
Has to contain hydrogen. And then, oops, I'm trying to move my screen over. Plus something else.
Binary one?
Trinary, kind of.
Oh, would this be with a metal?
No metals. This is still usually a nonmetal. Usually these are acids that are formed between hydrogen and a polyatomic ion. Like phosphate, nitrate, whatever. Okay? So binary acids are just 2 elements. Oxyacids are ones that contain more than that and always oxygen too. Those are the main 2 types. Okay? So now we're going to learn how do we name those things? How do we do that? Okay? We're going to start back with binary acids. Okay, and let's start with this example. H2S is a binary acid.
Wait, so is water acid?
Water is
Rain is-
neutral.
Rain. Isn't rain acid
There
water?
is some kind of acid.
So binary acids, we're going to take two elements that are put together. And when we build an acid, it should always be a neutral compound, just like regular ionic compounds. We need to combine our elements in a way that make it neutral. So when we took H2S, what I really did was I took a hydrogen atom and a sulfide atom, and I put them together, right? By doing the crisscross method or by just looking at how many hydrogens do I need to balance that sulfide, which is 2. So H2S.
So they're kind of like ionic.
It's exactly. We build them exactly the way we build ionic compounds. Except it's easy because hydrogen is always +1. So we just need to look at how many hydrogens do we need to balance my negative. Okay? So now the way we name this, the way we give a written name to an acid depends on what anion it came from. Okay? So what anion did this come from?
S.
S minus 2, which is called
Sulfide.
sulfide. That's really important. You have to be able to tell what anion did the acid start from. Okay? And this one, if we would take away H2, it would leave us with S minus 2, which is called sulfide. Okay? So I'm going to give you this little sheet to help determine how we name acids based on the anion they come from. And this is a sheet you'll get like on tests and stuff, so you won't have to memorize this. But I'm going to let you use that in the future. Okay, and it'll help us figure out which one to use.
Can you give us an extra one? Let me give you some.
Whatever you're supposed to.
Yeah. You got it.
Since I'm using sulfide, let's look at this. My anion ends in IDE. So the name of my acid becomes, you see right down here, IDE?
Yeah.
The name of my acid then becomes hydrosulfuric acid. H2S means hydro. Well, what anion did we use?
Oh,
We
you're
use
talking about this one up here.
right? Sulfur. Hydrosulfuric.
Wait.
He's talking about the one
Who
on the
came
wall.
up with this?
Wait.
The S
Not
is
me.
sulfur. So therefore,
that's
you put
right.
Hydrosulfuric.
What's the name of that one?
That's the name of my acid. Hydrosulfuric acid is H2S.
So if it ends in I, do we add hydro and it?
Right,
Say like it ended in I, though, we just add us?
right.
Oh, okay.
Wait.
Okay? Hydrosulfuric acid.
And we take out the I, right? And then add us?
If it was sulfide, it'd be
Sulfuric acid. We're going to do all of those practices.
sulfuric.
Okay, there is no rule for me to tell you what root of the word really gets to stay in with acids. It's usually after an R. That's really about the only rule I can tell you. So if you would have written hydrosulfic acid, I probably would have counted it right, but it just doesn't sound as right? You did the prefix and the ending right. The root of it was what was wrong. So when you're doing this, it usually comes after an R. Sulfuric acid, phosphoric acid. Okay, it's just kind of what sounds right.
Wait, slide.
All right, we're doing hydrochloric acid, so it means it comes from Cl minus, not chlorate, not chlorite. It's just chloride by itself.
Cl2.
No, it's just HCl, right? Yeah.
All right.
HCl.
Let's listen. Hold on. It comes from chloride, which we know is a -1 charge. So how many hydrogens do I need to balance that? Just one. So my final formula is HCl. Okay, just HCl.
Hydrochloride.
Hydrochloric acid.
So,
Wait.
like, what if it didn't end in like I? Then what would the name be?
Try this one. H3P. H3P. If I take away my 3 H's, if I take these away, I'm left with P minus 3, which is what?
Hydrophosphoric acid.
Phosphide.
This right here is phosphide.
So then it'd be
So I know it's hydro phosphoric
Yeah, phosphoric.
acid.
So we don't name the H in front of it.
No.
It's just
No.
it's just
The
anion?
H tells us it's an acid.
Okay,
right,
can
that's
you
what it's
just
telling
name
us.
the anion?
The anion helps us get to the name, right? Hydrophosphoric acid. The acid part tells us about the H. Right? So let's try, what if instead I had H3P, what if I had H3PO4? That's a totally different compound, right? H3P is what we just did. H3PO4, totally different compound.
It'd just be phosphoric acid.
Good. Okay, but let's slow it down a little bit, but yes, you're right. If I want to see what anion I was dealing with, if I ignore that for a second, it's PO4 minus 3, which is phosphate. Right? PO4 minus 3 is phosphate. And so now I look at my acid sheet and I say, how do I name acids that come from 8? And I say it's phosphoric. All I'm doing is adding that ic acid. No hydro in front of it, right? Binary acids are the only ones that get that hydro in front. Okay? Phosphoric acid. Right, it's usually phosphorus, phosphide, right? It goes back to that R. Phosphoric acid. Okay, why don't you guys, are we feeling okay about that?
Yeah.
Give me the formula for nitrous acid. Nitrous acid. Okay, let's walk through this one.
Nitrite.
Nitrous acid needs to come from nitrite. So first of all, you got to know what nitrite is.
N2.
No, not N2.
H2NO.
No.
It'd be HNO2.
What is the formula for nitrite?
NO2.
NO2 minus 1. So I have to pair that with a hydrogen. How many hydrogens do I pair it with?
HNO2.
So it's just HNO2. Okay? How are we feeling about applying each of those things? Do you feel like it's more difficult to go to the name or to the formula?
It's pretty easy for me.
You think going to the name is harder? All right, let's try a couple more of those.
Well, to the name is the easy part.
I'm going to give you one of each. One of each.
It's gonna be cheesecake.
Oh, wait, I don't want that one. Ignore that last one. Hold on.
Oh, we already did it, Mrs.
No, we didn't do that one, but it's the same as the top one.
I know the top one.
I want to make it difficult.
I do not kiss and tell.
All right, give me those two. All right, let's talk about this first one here. Raise your hand if you feel pretty confident in your answer for the first one.
Maybe like halfway.
Andrew, what do you think?
I don't even know what's that, so I just assumed the first one.
Perfect. Whoa.
Wow. We're gonna do carbonic acid. That is.
Oh, you're right. You're talking about where the root was. Yep, you're exactly right. Carbonic acid. Yeah, you kind of have to just go with what you feel like instinctually sounds right, right? Carbonic acid is good. Very nice. Okay, we know it's carbonic acid because it came from carbonate. If we take these away, that leaves us CO3 minus 2, which is carbonate. Good. Second one, bromous acid. Bromous acid. Micah, did you have that one? No? Okay. All right, Ethan, why don't you tell us?
HBRO2.
HBRO2. I would agree. So are we a little confused on how we got there? Okay, I wanted this one to be challenging, so I gave this one an extra step. What we need to be focusing on, don't put up your things yet, class is not over.
Oh gosh.
Bromous means that it comes from bromite. Is bromite anywhere on your sheet?
No.
But what is on your sheet?
Bromate.
Bromate. And what do we know about 8 to 8?
It's just one less.
One less oxygen, which means bromite is BrO2 minus 1. And if I pair that with a hydrogen, that gives me HBrO2. Perfect. Okay? 8 to 8, you need to remember that. Okay? Because I might give you things like that on your quiz on Thursday.